whenever I have a DIDT in the aggressor. And where do I have the DIDT in the aggressor? That is when I have the DIDT is when I have the edges. That's why we call it switching noise. And so I'm going to see the noise in my victim line. So here's channel 2. It's my victim line. This is the voltage noise in the victim line, shorted at the far end. I'm going to see the noise on him when I have the DIDT. So I'm going to bring them so they're on top of each other so we can look for that edge noise. And now I'm going to increase the scale, the sensitivity. I'm at 100 millivolts. I'm at 50 millivolts. And I'm just beginning to see the tiniest hint of a little bit of noise here. And so now I'm going to zoom out on this edge. So I'm going to grab the time base and I'm going to zoom out. So we're zooming out on this edge. Okay, here we go. So here is the DIDT of the aggressor. That's the current changing in the aggressor line. And here's the noise on the victim line. And you can see on the scale, it's about a millivolt. It's not much at all. In fact, you know what? I'm going to save that just so we can compare it. I'm going to zoom out just a tad here. Let's see, I'm going to zoom out a tad here. Now, they're not happening simultaneously, right? Because it looks like the noise is happening before the signal. And that's only because I'm going to go back to my camera view here. My current probe over here has an amplifier that is in the scope over here, and that amplifier has some delay in it. And so the scope measures the current through the current probe delayed from when it actually happens. And that's why we see the noise on the victim line happening before the current probe. It's just an artifact of the delay in the current probe because of its amplifier on the inside. But you see it's happening during that DIDT. Now that's on 2 millivolts of division. I'm going to save this just so we can compare it for a minute from now. And so I'm going to save it. I'm going to save the waveform. Let's see, it's currently in channel 2. I'm going to put that into memory location 1. And there it is. And I'm just going to move it over here for now to store it. Now, this is with a nice wide uniform plane. Very little crosstalk, right? Very little inductive coupling in this particular example. Now, let's turn on. Let's look at the other example here. And we're going to look at where we have the gap. And so all I'm going to do is I'm going to move my victim line over to my other structure here with the gap. I'm going to drive the aggressor with the function generator. And so we get the function generator going in. Here's my current probe going on the other end. And now let's look at the victim noise where I have that gap in the return path. And let's look at the scope. Oh my gosh, look at that. I mean, I'm off scale. You saw